Hello students, today we are starting the fourth part from metals and non-metals. Today we will start with metallurgy. Now what is metallurgy? Metallurgy is extraction of metals from their ores. Now what is this ore? We will learn after a while, but first the definition of metallurgy. Metallurgy is process. It is a process of extraction of metals from their ores which are found in nature. So now we understand what is this. In nature's crust, in nature minerals are present, and what are these minerals? These minerals are substances which are found in earth crust along with metals and some other impurities like sand, mud, rock, clay or other chemical compounds. It means on earth crust, if this is earth, on earth crust certain substances are found which are known as minerals, and these minerals, they have metals plus certain impurities, and these impurities are in the form of sand or rocks or other chemicals or mud or some other impurities. So from these natural minerals, different metals, they are being extracted, and these metals, they are used in our day-to-day life. So this is what are minerals. Now there is one other term, ore. As I have used that metals are extracted from their ores. Now what is this ore? Ores are minerals. All the ores are minerals. But what type of minerals? Special type of minerals in which the concentration of the metal is more. It is so concentrated that this metal can be extracted from the ores conveniently and with less expense, that is profitably. So from the ores, metals can be extracted profitably and with convenience or with ease. It means all the ores, they are minerals, but all the minerals, they are not ores. This is one thing. So in earth crust, these metals are present, and in seawater also we can have sodium chloride or salt is dissolved in seawater. Magnesium chloride is also dissolved in seawater. So from seawater also we can have sodium and magnesium. Both of these are metals. So from seawaters also sodium and magnesium, they can be extracted. But mainly the metals, they are found in the form of minerals in earth crust. Now how these metals are present in these minerals? Metals can be present in their elemental form, or they may be present in compound form. If they are free in elemental form, the metals are non-reactive, and if they are present in their compounds, the reactive metals, they are present in their compounds. And most compounds in which metals are present, they are oxides, carbonates, sulfides and even chlorides. These are again, although some more may be there, but these are the important one. Metals can be present in minerals or in ores in the form of their oxides, in the form of their carbonates, in the form of sulfides and chlorides. Chloride, as I have just told you, sodium chloride, magnesium chloride, calcium chloride. So these are in the form of chlorides. Then oxides, we have iron oxide, hematite, we have bauxite, aluminium oxide, carbonate, we have zinc carbonate, sulfide, we have copper sulfide, mercurous sulfide and other sulfides. So these metals, they are present in the form of carbonates, in the form of these compounds, different compounds. Then oxides, they are more frequent. Why the oxides, more oxides are, most of the metals are present in the form of oxides? Why? Because oxygen is present in abundance in nature, in our atmosphere. This is one thing. Second, oxygen is very reactive. It can react with metals to form their oxides. And the third point is oxygen forms stable oxides and ionic compounds are formed which are strong and stable. So most of the metals, they are present in the form of oxides. So this is how these metals are present in the minerals. Now which metals are present free? Which metals are present in combined form? So we know, we have learnt about the reactivity series of metals. Now I am writing again the reactivity series. All of you should learn this reactivity series. So this is up to hydrogen, and then copper, this mercury, silver, gold and platinum. So this is the reactivity series. This is a non-metal and we have one more non-metal here, carbon. After chlorine, this aluminium, we have carbon, non-metal in this series, as carbon is used in the metallurgical processes. And I will add one more, manganese. Manganese is a metal and it is after carbon in the series. So this is the reactivity series of metals and this is the order of their reactivity, that these are the most reactive and these are the least reactive. So the reactivity is decreasing like this from top to bottom. So we were discussing how are these metals, they are formed in nature. So it is found that these metals, gold, platinum, silver, this one mercury, copper, they are least reactive. They do not react with anything. So they are formed in free state. This is known as native state. So we can have gold in gold mines, silver, all these they can have in free state. But copper, mercury and silver, sometimes they are found in the form of their compounds also. But gold and platinum, they never form compound with anything. So this is the least reactive, and in nature this and this can be found in compounds, but these are free also and in compounds also. Then what about this? These are the metals of middle order, zinc, iron and lead. They are moderately reactive or they are in the middle. So these moderately metals, they are found mostly in the form of carbonate and sulfide. So zinc carbonate, zinc sulfide, this iron sulfide and lead carbonate and lead sulfide, they are found, and we extract metal from their compounds like sulfide and carbonates. So these three are in the middle order or moderately reactive. These five, potassium, sodium, calcium, magnesium and aluminium, these five are most reactive. So these are the top metals which are categorized under most reactive metals. First of all, carbon is below these 5, so they cannot be reduced by carbon. And they have more affinity with oxygen. So they are present in the form of oxides as aluminium, or they are present in the form of their chlorides. They are so reactive that they can only be extracted from their compounds by electrolysis or by electrolytic reduction. They can be reduced from their compounds only by high power of electricity, and electrolytic reduction is done for these highly reactive compounds. So this is how, based on this reactivity series, we have categorized into 3, and we will study one series at a time. One category, top reactive, then the second category, moderately reactive, and the third category, least reactive. And the extraction techniques, they are based according to their reactivity. Different techniques, they have been taken for extracting metals from these 3 categories. So this is how 3 categories are made. Now one thing more, there are few steps of metallurgy. There are 3-4 steps for metallurgy. The first step is concentration or enrichment of ore. Now all of you know what is ore? Ore, where metal is present in concentrated form. This is one thing, so that it can be extracted with profit and with ease. Now what is concentration or enrichment of ore? Suppose this is a block of a ore and metal is also present here, and these impurities, these are also present in this ore. These impurities which are present with the metal are known as gangue. What is gangue? Gangue is the impurities which are associated with metal or its compound in its ore. So what we want to do in concentration, we want to remove this gangue, and we want more concentration or more enrichment of this metal in a particular block. So this gangue is removed by different processes, and these processes, they are dependent upon the physical and chemical nature of gangue, and also the physical and chemical nature of the metal which is present in this block along with this gangue. So the removal of gangue or impurities is known as concentration or enrichment of ore. So different techniques which are used are the common technique. It may be magnetic separation. If iron is present, so iron is magnetic in nature, it can be enriched by magnets, large big magnets. So this is known as magnetic separation. Then there may be hydraulic washing. By this washing, all the clay, sand, rock particles, small rock particles, they are being washed away, and the metal is found in more concentrated state. So one is magnetic separation, then hydraulic washing, and third may be solvent separation. Solvent separation. So this solvent separation, if some impurities, they are dissolved in a particular type of solvent, these are dissolved, and these impurities, they are removed from this ore. So this is how the first step in metallurgy is concentration or enrichment of ore. The second step, this is the first step, and these steps are common for all the three categories of extraction of metals. The second is conversion to metal oxide. Suppose in the ore, the metal is present in the form of sulfide or in the form of carbonate. Then first the metal is converted to metal oxide. Why it is converted to metal oxide? Because it is easy to extract metal from its oxide in comparison to carbonate and sulfide. So first of all, conversion of carbonate or sulfide is done to the oxide of the metal, and mostly this reaction is done in the middle order series. Middle order, that is for moderately reactive metals like zinc, iron and lead. So for these metals, first of all, conversion to metal oxide is done from carbonate and sulfide, and particular techniques are applied which we will discuss later. And the third point is now reduction of metal. From this metal oxide, the metal reduction is done, and this oxide is reduced to the pure metal. So third is reduction of metal, and reduction can be done mostly by coke or carbon, and it can also be done by carbon monoxide, carbon dioxide or ammonia. So different processes of reduction are there, but mostly it is done by carbon or coke. And the fourth one is purification of metal, and this purification is done mostly by electrolysis, and it is known as electrolytic purification or electrolytic refining. So these are the four steps in metallurgy. First is concentration of ore, second is conversion to oxides, third is reduction of metal from its oxide, and oxide or chloride, whatever is this, but reduction of metal, and fourth is purification by electrolysis. These four steps, they are used in all the three categories: highly reactive, moderately reactive and least reactive. Here we are seeing that reduction is done by coke or carbon. So, and here we are seeing that carbon is present below these 5 reactive metals. So carbon cannot displace metal from its compound because it is less reactive than all these 5. So carbon cannot be used for reduction of all these 5. It is less reactive than these 5. That's why they are being extracted by electrolytic reduction. Their reduction is done by electricity or electrolysis. So they are extracted by electrolytic reduction. Now we take all the three categories one by one. First of all, I will take extraction of metals from low reactivity series. High. So first of all, we will take the high, the most reactive metal. So first of all, we will take extraction of metal from high reactive category of metals. extraction of metal from high reactive category, which are on the top. What are these? We will take example of sodium and aluminium. Others are magnesium, calcium and potassium. So we will take these two examples, sodium and aluminium, to extract by electrolytic reduction. So this is the electrolytic cell, all of you know. Now you know what is an electrolytic cell. This is a container. In this container, electrolyte is there. So the solution which is filled here, it is known as electrolyte. This is electrolyte. It is filled here. Now these two, they are electrodes. The common name is electrode. There are two electrodes. One electrode is negative, the other electrode is positive. The negative electrode, it is known as cathode. The positive electrode, it is known as anode. This all of you know. And these electrodes, they are made up of graphite. Graphite is carbon and it is conductor of electricity. So though carbon is a non-conductor, but in the form of graphite, carbon is conductor of electricity. So these electrodes, they are made up of graphite. Now they are put in this electrolytic cell and they are joined with the electric circuit. This is the battery and these two electrodes, they are joined by the conducting wire to this battery. What happens, and suppose we have taken molten solution, molten NaCl in this electrolytic cell. That is NaCl, the common name is rock salt. NaCl, sodium chloride, the common name is rock salt. It is, first of all, it is taken into molten state and this molten NaCl is filled in this cell. Can you tell me why we are melting this NaCl? Why it is taken in molten state? Because NaCl, all of you know, is ionic compound, and this ionic compound, it is the ionic compound and it has these ions which are present together with each other, and a very strong ionic bond is present in between sodium and chloride ions. So these ionic compounds are very strong. So if they are melted, then this ionic bond is broken and the two ions, now they are roaming freely in this solution or in this container. Once the two ions, they are separated, then they are able to conduct electricity. If they are not free, then they cannot conduct electricity, because current, it needs ions to flow. So this NaCl, it is melted. So we have taken, here I have written electrolysis of molten NaCl, or you can write electrolytic reduction. Electrolytic reduction of molten NaCl. We are reducing this NaCl to get sodium metal. So NaCl is taken in molten state. It is filled here when it is connected with battery. This is the negative end of the battery. From the negative end, these electrons, they are released. And these electrons, they will go on this side. They are going in this side and they will come to this cathode. Cathode is negative terminal, and the sodium ions which are present in this solution, these are positively charged cations. These are attracted by these electrons which are coming from this side of battery. Now these electrons, they are being taken by sodium ions and it become neutral, and ions, they are being absorbed by this sodium ion. You can see here 2Na. This is the cation and it absorbs 2 electrons, 1 each. So 1 Na will absorb 1 electron. These charges, they are neutralized, and now Na metal or sodium metal is formed. So on this anode, on this cathode, sodium metal is formed when positive charge is neutralized by the electrons which are coming from the negative side of the battery. This is a story on cathode. Now what is happening on anode? Anode, the Cl, the anion of NaCl, it is negatively charged and it is attracted to the positive electrode or anode. So these chlorine ions, they come to this anode and they are having negative charges, and these two, they lose these electrons on this anode. They are having more. All of you know how NaCl is formed. Cl is having 288, 1 electron more. Sodium is having 28, only 28, 1 electron less. So it gets 1 electron from here and they are having 288. In the last shell, they are having 8 electrons, 1 electron more. That's why they are having negative charge. They want to lose this electron, and 1 each electron is lost by these chlorine ions. So when this is 2Cl minus, when 2 electrons are used, it becomes Cl plus Cl. Chlorine gas is formed on anode. Is it clear to all of you how these gain electron and these, they lose electron? By losing 1 electron each, this chlorine gas is formed and 2 electrons are released on anode. Now these 2 electrons, they enter the battery and they are ready to come again to the cathode. In this way, this cycle is completed. This sodium metal, it is deposited on cathode, which we can have after this experiment, and this chlorine gas, it is released on anode. So this is how extraction of sodium or reduction of NaCl is done by this electrolytic method. So you can see the equations here. This is the overall equation. NaCl by electricity, it changes to sodium and chlorine. These we have discussed. Now one thing more, as you can see here, I have written 2 abbreviated words here. You should learn them, remember them. One is PAO, P-A-O. The other is NCR. Have you heard NCR, National Capital Region near Delhi? So this is the same NCR. The word is NCR and here it is PAO, like pav bhaji wala pav. So this is PAO and this is NCR. What is the full form of NCR? Negative cathode reduction. And for negative cathode reduction, what does it mean? It means cathode is negative and reduction of metal is done on cathode. And how do we know it is reduction? When electrons, they are added. When electrons are gained, then it is reduction. If electrons are lost, then it is oxidation. So this you will learn, you remember by these 2 words. Here this is negative cathode and reduction is taking place at this cathode. And when reduction is done, then these electrons, they are gained. So this is how NCR and PAO is positive anode oxidation. Positive anode oxidation. What does it mean? Anode is positive and oxidation is there is taking place on anode. How oxidation is taking place? When electrons are lost, then it is said oxidation is occurring. Oxidation is taking place. So here this chlorine is formed by oxidation and sodium metal is formed by reduction. So you should know POW and NCR very easy to remember. So this is NaCl, molten NaCl reduction to get sodium metal. We can take one more example. The second example, it is aluminium oxide. And this aluminium oxide, the common name is bauxite. The name of the ore is bauxite, and aluminium present in this bauxite is known as alumina. When it is enriched or concentrated, then the white powder which is present in this bauxite is known as alumina. This is the common name of aluminium oxide. So this is also taken in the form of molten alumina, molten bauxite, and the formula is Al2O3. All of you know the valency of aluminium is 3, the valency of oxygen is 2. So when electricity is passed, this is the overall equation. 4 atoms of aluminium are present and 3 atoms of carbon, this oxygen gas is formed, and this arrow showing the gas, oxygen in the gas form and aluminium metal is formed. How this overall equation arises? Here instead of NaCl we have Al2O3. On this aluminium we will get aluminium, and on this oxygen gas is evolved. The same thing again, and the equation is aluminium has the valency 3. So to get 4 aluminium it needs 12 electrons. So from here 12 electrons they are coming, and 4Al3 forms 4Al reduction at cathode. And this is 4Al and this is 6O, not O2. If we want 3 molecules of oxygen, then 6 atoms of oxygen are needed, and 1 atom, the valency is 2. So this will lose 12 electrons and will form 3 molecules of oxygen, and 12 electrons are lost, and these 12 electrons they are being gained by as the valency is 3 here, valency is 2 here. You remember all these equations, and so aluminum oxide is also reduced electrolytically, and on cathode we get aluminium metal, and on anode we get oxygen gas. So this is about the extraction of metal in highly reactive category, which are at the top of the reactivity series. So the other 2 categories we will do in the next video. This is part 4 of metals and non-metals. This is all. Thank you.